For someone who doesn't know, what does the principal investigator of ESCAPADE do?
So the principal investigator is entrusted by NASA to execute the entire project. So it's kind of like the buck stops with me. I have a team of excellent people around me, but I'm responsible for the production of the data, the definition of the science requirements, the execution, the technical aspect of the mission. I think it's a great model for how NASA sort of entrusts the completion, execution of a mission to a partner like UC Berkeley, where I'm based.
And ESCAPADE is a really special project. We are so excited to be taking it up today on NG2. Tell me a little bit about what ESCAPADE does.
So ESCAPADE is a twin spacecraft mission going to Mars, orbiting Mars to sample the ways in which Mars and its upper atmosphere respond to changes in space weather. By space weather, I mean the million-mile-per-hour stream of charged particles that the sun is at all times throwing out. Sometimes that stream gets gusty, and the gustiness, essentially, of it is what we call space weather. And there's all sorts of ways that can happen. The magnetic field can get stronger, the speed can get higher, the density can get higher, and all those things have an effect on the Martian atmosphere. And over time, it can strip away the particles in the upper atmosphere. And we know that this has been an important process by which Mars's climate has changed over Martian history. Early in Mars history, up to about 2 billion years ago, Mars was at least occasionally warm and wet. It had a thick atmosphere. It was habitable. We don't know whether life actually existed, but it was habitable there. But then in the last 2 billion years, it's lost most of its atmosphere. And we think that the stripping of the atmosphere by the solar wind is a big reason why that happened. And ESCAPADE is going to be sampling and investigating these processes with a stereo perspective, with 2 spacecraft. And that's really important because up until now, with one single spacecraft, we've only been able to measure either the solar wind itself or the effect of the solar wind closer to the planet. We've either had the cause or the effect, but separately. With ESCAPADE, we can have 2 spacecraft simultaneously cause and effect at the same time. And so that's the breakthrough that ESCAPADE is going to provide us in understanding the processes by which the atmosphere is stripped away.
And once we understand that, I mean, how does that affect us here back on Earth or future Mars missions?
Right. So it's important for a couple of reasons. One, I think we're just curious as to how planets evolve in general. Right. Like over the billions of years, planets, they change their atmospheric composition. They're more volcanically active, and that can affect the atmosphere too. And so this is an important piece, isn't the only piece, of course, but it's an important piece of the puzzle of Mars climate evolution. And that's interesting just because we love to explore as humans. But it's also important because space weather can have a practical effect on robotic spacecraft that we send to Mars future and also humans when they explore Mars. This is important for a couple of different reasons. One, a big space weather event, what's often called an interplanetary shock or a coronal mass ejection, when the sun belches out a couple billion tons of hot plasma, often at high speed, high density. As that shock expands through the solar system, it accelerates particles to really high energies, high enough energies that they can go right through a spacesuit and cause astronaut health problems.
Right.
And so the radiation on the surface of Mars, when you get a big enough coronal mass ejection, you can get 100 days worth of radiation in one day. This happened last year.
Wow.
This happened last year, June 6th, 2024. The usual background level of radiation was increased by a factor of 100 for that day when that happened. And so if you're an astronaut on the surface of Mars, you don't want to be out away from your radiation shelter when that happens. And so ESCAPADE's measurements are going to enable us to better forecast those radiation hazards. There's another reason too why ESCAPADE's important, because we're also going to be studying the ionosphere. So this is a layer of gas in the upper atmosphere that's ionized. And that's important because that layer, it distorts radio signals as they pass through it. And understanding the variability and the structure of that ionosphere will help us to correct for those distortions.
For communication.
Communication, but also for navigation, because there's going to want to be GPS on Mars eventually. And understanding how the ionosphere distorts the GPS signals will enable astronauts to know better where they are. All these things are taken into account on Earth. It's all behind the scenes. So your phone doesn't have to show you how they're correcting for it, but that's all behind the scenes on Earth. We want to be able to do that same error correction on Mars, and ESCAPADE will help us understand the ionosphere.
It's really cool to know that we're thinking about these future problems now.
Yeah.
And speaking of things that are happening in the future, I mean, ESCAPADE is not going to be making it actually to Mars. The spacecrafts aren't going to be there for at least 2027.
That's right. That's right indeed. Yeah.
So what happens once ESCAPADE deploys? Kind of tell me more about the trajectory.
Okay, well, so after it deploys, first of all, there's a few important checkouts we have to do. The first thing is we got to deploy the solar panels and we got to get it to speak to us. And so actually, the viewers will be interested to know that we may not hear from the spacecraft for up to 3 hours after launch. And that is by design.
Okay.
Because we have two antennas, one on either side of the spacecraft, and they only work one at a time. And we don't know which one necessarily is going to be pointed towards Earth initially. So if the one that turns on first happens to be pointed away from Earth, we got to wait 2 hours until it decides, oh, I'm not hearing from Earth, and it switches over to the other one. So no one should panic if we don't hear from it within that first hour. But once we know that we have signal, we're hearing from it, and we know the solar panels are deployed and they're facing the sun, so that's called power positive. So it's a safe and a stable mode. Then we can relax, and then we can start focusing on the longer term aspects of the mission. And you mentioned trajectory. So yes, we are taking quite an unusual path to Mars. We are going to spend about a year in a very large Earth orbit, fairly gravitationally bound to the Earth. We're calling this the loitering phase. It's in the shape of a kidney bean. It kind of goes like this. And next November 2026, we're going to come back to Earth after going more than 2 million miles away. We're going to come back to only 600 kilometers above the surface. We're going to use Earth's gravity and burn our engines at that point, taking advantage of Earth's gravity to slingshot ourselves toward Mars. Because early November next year is when the interplanetary window opens for a transit from Earth to Mars. So all Mars missions before us have had to wait until this narrow 3 or 4 week window every 25 months. We're launching halfway between these two windows. So we're just going to kind of hang out in near Earth space until it's time to go to Mars. And this has never been done before. And this is really, really exciting because this actually opens up the possibility in the future. If humans want to actually settle Mars, we're going to have to send hundreds, maybe even thousands of ships to Mars within that 2 or 3 or 4 week window. And there aren't enough launch pads on Earth to reliably do that just within that window. So we could launch them over the course of a whole year, maybe, and we could like sort of queue them up,
right,
so that they're kind of lined up so they can go when that window opens. And so this is hopefully going to pioneer a way to essentially enable interplanetary settlement in the distant future. Who knows?
And once the mission actually starts, how long is the mission going to be going on?
So, so I mentioned November 2026. That's when we start our interplanetary cruise. We spend 10 months in that cruise to Mars, doing little trajectory correction maneuvers all the time, little tiny engine burns to like just, barely tweak our path so that we can intercept Mars in early September 2027. And that's when we got to do another big engine burn to be captured by Mars's gravity. And that's when we will be in Mars orbit. Then we spend another 7-8 months-ish adjusting the orbits.
Wow.
So first of all, lowering the orbits, then adjusting the orbits. And this is important because ESCAPADE is doing another thing that's never been done before, which is the first ever formation flying around another planet other than the Earth or
a lot of firsts on this
the
one.
Moon. It's kind of like pearls on a string. Both spacecraft have to get into the same orbit. And it takes a while to adjust both orbits to make that happen. And also in the middle of that, there's what we call solar conjunction, where the sun gets in the way between Earth and Mars, and we can't talk to it for a whole month. So we kind of just have to chill out, go into safe mode, and just wait. And so this is the reason why it's going to take us an additional 7 months after we get to Mars before we can start the science mission in spring 2028. And then we have an 11-month science mission, and that's also in...
So this is going to take us all the way into 2029.
Yes, exactly. Yeah. It's, I think, May 2029 is the nominal end of the science mission. And I mentioned the 2 spacecraft are going to be the pearls on a string. We do that for the first 6 months. And that's important because we want to know how the upper atmosphere of Mars is changing minute to minute. So in the past, with only single orbiter missions, we've had to wait 4 or 5 hours to see how things have changed. And by that point, the planet's turned a quarter rotation, things are different. We don't know how anything changes on short timescales at all on Mars. ESCAPADE is going to pass through the same part of the upper atmosphere twice in a quick succession. So 2 minutes to 30 minutes apart to see how it changes on those short time scales. Once we're done with that, then we raise one orbit, we lower the other orbit, and then the 2 orbits are different, and they start precessing. This is a word for for the orbital planes moving with respect to each other.
Okay.
And this allows the two spacecraft to get much further apart from each other to make those simultaneous cause and effect measurements that I mentioned earlier, to understand the real-time response of the upper atmosphere to the space weather events.
And so with all that, understanding how ESCAPADE works, knowing that this mission is going into 2029, how do you feel today?
I feel excited. I feel a little anxious, as everyone does on launch day, but I am super, super excited. I'm proud of everyone who worked on ESCAPADE at Blue Origin, at Rocket Lab, at Berkeley, at Embry-Riddle, all of our partners. Advanced Space LLC, they were the ones who did most of the work to design this innovative path to Mars as well. And so I'm just so proud of the whole team. Probably thousands of people have worked on bits of it up to this point. And we're so excited to reach this day, the culmination of so much effort and the beginning of the next chapter.
And the last question I have for you is something I ask everyone, and that is there anything else you want to add or say or mention that I didn't ask about that you think is important to this interview?
So ESCAPADE is a very low-cost mission. ESCAPADE is only about 1/10 of the typical cost of a NASA planetary mission. This is a radical experiment by NASA in seeing whether they can accept slightly higher risk and less oversight in exchange for a much lower cost. And the idea being that overall you get way more science per dollar if you do this. And
We call it bang for your buck.
bang for your buck, science for your dollar. And it's because we are embracing, as I said, a lighter sort of a touch by NASA. We're using more commercial off-the-shelf parts. There are fewer reviews. There are fewer sort of requirements. NASA's kind of letting us run a little more than they would typically.
Okay.
And NASA's oversight is often what drives a lot of cost. That's great, but it does come at a cost. And so this is hopefully a new way of doing at least a fraction of NASA's science portfolio with this higher risk, lower cost approach.
It's very exciting to have you here, to be able to interview you.
This is an exceptional sight. Just watching pieces of other rockets being put together and knowing that our booster, our upper stage,
It was all built right here.
it was all built right here. The fairings, the
Yeah.
payload adapter, it was all built right here. Yeah.
Well, Rob, thank you so much. I appreciate your time.
Cheers. Bye-bye.